Okay, 2.1 vertex form of quadratic functions. We are going to be identifying key features. If you did the homework last night, that's what you were doing. So, first of all, we are going to have the reminder of standard form, and we did that yesterday. Yes? Standard form was ax squared plus bx plus c. Yes?
Yes.
Okay, so the quadratic function, parent function, is f of x equals x squared. No left, right, up, down movement. It looks like this picture. Remember, the vertex is h and k. If you don't remember that, you need to be writing the vertex is h and k. Can you unplug, please? Thank you. Anybody else plugged in? Unplugged? Matthew, you unplugged?
Yeah.
Just making sure.
Yeah,
Okay,
glare,
so
that's it.
the vertex is h and k. Those are the variables. We have the parent function goes through 0, 0. That is the point we will be moving up, down, left, right, reflecting. The graph of a quadratic function is called a parabola. We know this, yes? And we have the vertex form is f of x equals plus or minus a x minus h squared plus k. We dealt with that a whole bunch at the beginning of the year, haven't we? Okay, we're going to keep dealing with that. Algebra 2 is quadratic. It's built all around quadratics. We'll be doing other forms also, but our main one we have to get down is quadratic. So this plus and minus on the A, does anybody remember? Are we all down to at least the vertex form? Let me know when you are, because I have a better slide for the vertex form. The next one is better.
On to the vertex.
Thank you.
She literally did that. I don't want to hear it.
I want to make sure everybody's there. Am I good to go?
No.
Yes.
Not even halfway done.
Okay, so you need to start rewatching the videos rather than taking pictures, because that doesn't do you a whole lot of good.
When I write down, yeah.
Okay.
I just watch the video. The pictures are there.
Okay, I'm gonna switch to the next slide. It will be better. Are we to the
Okay.
vertex form?
I'm ready.
Okay. So this is all what happens. Remember me writing this on the board? Remember? It was written on the board for like 3 weeks.
Yeah.
Okay, so f of x equals plus or minus the plus or minus. If a is greater than 0, is that positive or negative?
Do you want us to write all this?
You need to write what you need. What does a greater than 0 mean? Positive or negative?
Positive.
Positive. So when a is positive, it opens what direction? Up. We reviewed that yesterday also, didn't we?
Yeah.
If a is negative, it opens what?
Yeah.
Down. Okay. A, the absolute value of a is greater than 1. The graph changes quicker than the parent function, making it narrower. The book, I think, calls it a vertical stretch. I call it narrower or wider, because you guys say it stretches. That's not specific enough. Yeah, Matt, you should watch the video and write that down also. Okay, if a is between 0 and 1, so that is a proper fraction, correct? And that's an absolute value because the plus or minus is open up or no. If a is between 0 and 1, the graph changes at a slower rate because you're taking half or a fourth or 2/3, right? So it will be wider.
So you are recording this?
Mm-hmm. It will be wider. The third bubble is pointing at the H specifically, but it's in the quantity. H stands for horizontal, left or right movement. There's a lot of words there. Okay. H is the horizontal translation of the vertex, always opposite sign. If H is negative, the graph goes which way, right or left?
Left.
Right.
Right. If H is positive, the graph goes. If H is positive, the graph goes left. Okay? X equals H. That is the axis of symmetry. H, I don't know if that should, H is the X value of the axis of symmetry. So that's what that should say. H is the X value of the axis of symmetry. Okay? It should be a little like indent right there. How about H is the X value of the axis of symmetry. I know why they wrote it the way they did, but sometimes that's confusing. That is really sloppy. Okay, if H is greater, if A is greater than 0, H is the minimum. All that is doing is telling you whether this is a min or max. If it opens down, is H a min or a max? If it opens down, is the vertex going to be a minimum or a maximum? Maximum. If it opens up, minimum. That's all that says. Okay? You don't really need to write that down if that makes sense to you. Okay? K is the vertical translation of the vertex. H has a lot of stuff in it. So H is going to tell you a lot about this graph. Yeah. It's the X value of the axis of symmetry. It's the horizontal movement of the vertex. You know, it's a max or minimum. When we talk about graphs, we talk a lot about the X value of things. Y just kind of comes with it. If I tell you this happens at the X and you know the function, you can always plug in the X to find the Y. So Carly's gone, right? And Angela. Anybody else? No. Okay, you guys ready? Ainsley, you good?
Yeah.
Okay. Just making sure. Okay, so this is just showing you what you just wrote. You don't have to write this down. Okay? You do not have to write this down. This is just an explanation of what we just wrote. Okay? So this is negative. So is this graph going to go up or down? Down. It's going to open down, right? And A is 1/2. So is it going to be wider or narrower than the parent function? Wider, because it's going to change slower. So the blue is the parent function. And then the red, I say wider. They in the book say vertically compressed. This is my problem with this, guys. People will say it's a stretch. Okay? It's a stretch. They just say stretch. If it's stretched, do you need to tell me which way it's changing? Yes? Is it easier just to say narrower or wider?
Yeah.
Yeah. Okay? Now I have 2. Oh, I guess I didn't talk what else happened. What's this +2 do to my vertex?
Left, right.
It goes left, how much?
Right. 2.
2. So did the vertex go left too?
Yeah.
Yeah. It didn't go up or down, did it? Okay, so I have a positive 2. So up or down? Up. Positive 2. Up. Wider or narrower? Narrower. What's this negative 1 do to it?
Move it to the right.
Okay, so 0, 0. I'm just going to say 0, 0 is going to go to 1. And what's the 3 do? Nope. Down. That one's the same way. Down 3. So let's look at this. The blue is the parent function. Got it? Okay, so we said the vertex is going to go to 1, negative 3. Did it go to 1, negative 3?
Yeah.
Is it narrower
Yeah.
than the parent function? Yes. When you do these will be sketches, guys. When you have to sketch it, graph it. I'm not going to give you graph paper. If I give you graph paper, then you have to start getting exact. Do you want to get exact with things? No. All you have to do is put a little line here that says negative 3. Put a little line here and put negative 3. And put a line here that says 1. And is your vertex right there? Yeah. Yes.
It's like on B, like 2, which would be A. Is that basically just the
It is kind of the slope, okay? Slope, by definition, is the rate of change, okay? But the rate of change of a parabola, is it consistent?
No.
No, it is not. So we can look at it kind of like the change of, like the slope, but it's not specifically the slope. Does that make sense?
Yeah.
It's telling you a rate of change. It's not telling you the slope because there's not one slope. There's actually infinitely many slopes because there's infinitely many points on this graph. Is there not? Yeah? And so if I made all the points on this graph and I wrote tangent lines, a tangent line is a line that touches at one spot, I would have infinitely many slopes. So yes and no. It's not a slope, it's a rate of change. Other questions? Okay, describe the transformation of from the parent function. Identify the vertex, the axis of symmetry, the minimum, domain, and the range. Okay, now real quick before we do this, I'm going to go back here and go back. Mine went back. Yours didn't. Oh, it's a little slow on the uptake. Looking at the blue function here on the left. What is the domain of any parabola? Did I put anything in I want it? Yes, it is all real numbers. Yes? Okay. Of this parent function, my range, my output is y is greater than equal to 0, isn't it? Okay. So when I reflect it, it wouldn't be greater than equal to 0. It would be what? Less than equal to 0. So when we have some reflections, are we going to have to think about our range a little bit more? Yes. Okay. And I will tell you right now, a quick little sketch will solve your issue with range immediately. Because when we graph a line or a function, you're actually seeing all the y's. Okay, so we're going to go straight across. What does this negative do? Nope. Reflects. So we write reflects over what axis? X-axis. Okay, so it reflects over the x-axis. So we took care of that. This plus 2 is what variable, h or k? H. So that means that 0, 0 is going to go to where? Negative 2, 0. Because it's not going up or down, is it? So this is the vertex, is it not? Because there's no plus or minus over here. There's no K hanging out. Okay, so we got the vertex. Oh, we need the axis of symmetry. So guess what we're going to call that? AS, for axis of symmetry, is the X value, or the H. What's H? Not 2. Negative 2. Because this is H and this is K, yes? Yeah. Okay, so we got the axis of symmetry. Check. Min or max? So it opens, if it reflects over the x-axis, my picture should look like, if I make myself a little sketch, it should look like this, yes? So is my vertex a min or max? Max. So my max is, what's my max? Negative. You can put either x equals -2 or you can put -2, 0. Either one. Is it both the max? Yeah. Okay. So we got min or max. Domain. Well, the domain on any parabola, unless it's an application problem, is all real numbers. So x such that x is the set of all real numbers. And range. So the parent function is greater than equal to 0, correct? But what's our max y value now? It's 0. Is it going to be greater than 0 or less than 0?
We don't know.
Yeah, we do. It opens down. Less than. No, it opens down so y is less than equal to 0. And again, I knew it was less than because it opens which way? Down. Okay? This is going to come from K. Guys, what's our K right here? 0. Okay? This comes from K. This sign comes from which way it opens? And when I mean opens up or what? Down. Kind of becoming a little bit clearer than mud?
No.
No?
It looks like a mud bath.
A mud bath? Okay, so let's do it again. Walk across. We're going to cross this equation like this. Yes? So my leading coefficient is what? What's right here that's not there? It's a positive 1. Yes? So what's it going to open up or down? Up. So it's going to look like this? Yes. It's positive. That's how you know. It's positive. There's nothing else to it, guys. It's positive. It opens what? Up. If it's negative, it opens what? Down. Nothing else to it. Okay. So it's going to be the same width as the parent function because we have a 1 here, don't we? And I haven't really talked about that yet. But, okay, so we have an H and we have a what? K. So this is H and this is K. So my vertex was 0, 0. And now it is 1, 2.
I see the canine.
Okay? It's 1, 2. And again, opposite direction on the H. Yes? Okay.
Decided it's the opposite. Right?
Whoever wrote the equation. Well, first of all, the equation says minus. And so when an equation says minus, that's always going to be the opposite sign. Because if you have a positive, it's going to be negative. If you have a negative, it's going to be positive.
But like, why is it like that? Why didn't they just make it simpler and make it?
Because it doesn't work. It mathematically doesn't work. It has to work. Okay, so axis of symmetry. Do I need to write more than AS so you know what it is in your notes? How about axis of sim? Is that better? Okay, so axis of symmetry is x equals h of the vertex. And what's the h of the vertex? 1. And I'm writing it like x equals h equals 1 so you remember. Okay, then what's the next thing we have?
Max.
Min or max? Is it a minimum or a maximum?
Minimum.
Minimum. How do you know? Because it opens. Okay, a minimum at x equals 1. Or you can write it as 1, 2. And usually they say x equals 1 because it'd be a vertical line through 1. Okay. And then, what's next?
The range.
Domain.
Domain.
The easy one. What's domain?
X equals all real numbers.
X such that X is all real numbers, or you could write it parenthesis negative infinity, comma, positive infinity, right?
It'll always be like that.
Unless it's an application problem on a parabola, yes.
I'm not gonna ask what that is.
Yeah.
A parabola?
No, an application problem.
A word problem?
Um,
Because if I had,
So like number two.
well, because you're applying it. Because like if I had an equation that was quadratic, but I was dealing with area, can I get negative areas? No. So anything that would give me a negative doesn't work. Okay, lastly, range. Yes? How do I get range? Where do I look? The K. So I have Y and I have 2. How do I decide if it's greater than or less than?
Greater than. No, it's less than.
No, you're. It's the way it opens.
One of
Yeah.
those.
Okay?
Less than the equal to because it goes
It's
up.
No, no. Here's 2.
Greater than. Greater than.
It, it's a minimum, yes?
Greater.
So it's right here. There's 2. So everything else is what?
Greater.
Greater. Is that going to take some practice?
Absolutely.
Nah.
You can hear my rocks rattling, can't you?
This week you're gonna have a hard time. Teach us.
We good?
Yep. Nope. Not really, but sure.
Miss Smith, I just want you to know this is the lesson that I cried over for 2 hours.
Well, hopefully it's only an hour this time. Okay. Baby steps, baby steps. Okay, try this one on your own. Try this one on your own. Draw yourself a picture, open up or down, go through the same steps. You have the last example on your paper. Model it. Ainsley, Connor,
What if I just take a nap instead?
Matthew, I don't appreciate the attitude or comment. Thank you.
No worries. This is like reading. Yeah. Factors here. Papers negative two.
Go straight across. What's this negative do, Kyson? Does it open up or down?
Up. Down.
Open. It's negative. Think negative is where? No. So it's going to look like this. Just move across the equation left to right, guys. Then you don't miss anything.
Okay, how do you know if it's minimum or maximum?
Because look at my shape. What's it going to be? It's going to be a max because it's going to go up to it and come back down, isn't it?
Wait, on range, how do I know if it's greater or less than?
Okay, I'm looking at my picture here, right? And this right here is my vertex, where I get it from. So are they bigger than that or less than that?
Bigger? Less than?
No, stop guessing. Okay, right here is my vertex, that red dot. Are my y values above it or below it? Where's my graph? Above that dot or below that dot? Here's my red dot.
Okay, then it's
The-
all the numbers are below
And
that.
where's my graph going from that dot?
Down.
Down. So the y's have to be less than.
How do you know if you how's your name?
Okay, I was trying to make sense.
This does not make any sense.
Okay, when you go through this graph, guys, this equation, not the graph. This negative right here tells me what? Reflects. This is the H, and this is the
Okay.
K. Every single time. And if there's nothing there, then the value is what? Zero. Yes.
Is it always going to be the less than or equal to or greater than equal to?
Yes.
Never going to be, okay.
Yes.
So if it's
Fantastic.
positive, does it reflect over the y-axis?
No, if it's positive, it just opens up. If it reflects over the y-axis, you would have negative x. It would be on the x.
Okay. Yeah. How am I supposed to know that?
But are we done with this slide? I'll show you something real quick. Okay, I'm going to go back to this picture right here. If I take this blue on the left and I reflect it over the y-axis, what's it going to look like?
It's the same thing.
The exact same thing. So we typically don't reflect parabolas over the y-axis because I could just move it left to right to get what I wanted. And it's easier in our brains. Our brains do not deal with reflection over the y very easily, and I don't know why.
It does negative axis to reflect over the y-axis.
Yes,
So if the graph opens down, y is going to be
less than. Yep. If the graph opens down, y is always going to be less than on my range because my graph, it's always below it. Okay, so let's keep going here. Okay, so this is the other part of your assignment. It says, what is the equation of the parabola with a vertex of 1, -4, which passes through -2, -1. Okay, so first of all, we need to remember the equation in vertex form is what? Y equals, what's the equation? Y equals a,
Plus B.
no, quadratic, guys. It's on the first slide. You wrote it.
Plus H.
X minus H squared plus K. Okay, this will not be on the board this time when we have this test. You have to know it this time. Last time I put it on the board and I left it there, didn't I? This time I am not.
Can I put it on the board?
No. Okay, so it tells me the vertex. So this is the vertex. So 1 is what variable? H, K, X, or Y?
X.
No.
Why?
H. Why? Because it's the what? Vertex. Correct? If it is the vertex, this is an H. What's -4? K. So, -2 and -1. -2. X or Y? X. And Y. So I now have HKXY, and in this equation I have a Y, A, H, X, and a K. So I have 4 out of the 5 variables. Can I solve for the other one?
Yeah.
Yep. So what's Y?
Y.
What is Y?
Negative.
-1 equals, we don't know A, do we? A,
-2 minus 1
squared.
plus -4.
How about just -4? Okay. All I did was plug in H, K, X, and Y, correct?
Yes.
Do you need to make sure you have H and K in the correct ones?
Yes.
Yes. And now I'm going to order of operations. So -2 and -1 is
-3.
-3 squared is. So negative 1 equals 9 times A minus 4. Just following the math, right?
Wait, how do you add the 1 over?
Because negative 2 minus 1 is negative 3.
Okay.
Okay? Then I do what, Cole? What's wrong?
Nothing.
Are you sure?
Yep, I get it. No.
Okay. Now, put the 9 in front of the A. If you leave the 9 behind the A, you'll try to take 9 minus 4. And can you take 9 minus 4? No.
Yeah.
Because it's 9A.
Add the 1.
Add the 4.
Okay. Fine.
3 equals 9A. Then what?
A equals 3.
No, it doesn't. A equals 1/3.
Why?
Oh,
You have to divide by 9. You can't divide by 3.
Where do you get
I thought we
9
had to
from?
divide by 3.
Negative 3 squared
And then you square it back.
Okay.
is 9.
That's where I was confused.
Why do we have to divide by 9?
because you're solving for A.
That's fine.
So you have to divide by 9. Because it's 9A.
Yeah, it makes
Those
sense.
pesky
now.
algebra rules. Okay, so now do I have A?
Yeah.
Yes? So Y equals, what's A?
1/3.
1/3. X, what's H?
Minus 1.
Minus 1
Squared.
squared
Minus 4.
minus 4. So this is my answer. Now, in an equation, do I have to have an X and a Y in an equation? Yes. If I don't, is it an equation?
No.
No. It's not an equation if I don't have X and Y in the equation.
So this is all you gotta do.
So we have to find what?
And then you have to grab
A. And then you have to what?
Put it back in.
Put it back in. So in your homework, you're going to be describing the change. Yes?
Yep.
And you're going to be writing an equation. If I ask you to graph this right here, could we do it?
Yeah.
Okay. So the vertex is at 1, negative 4, yes? Yes? Does it open up or down? Up, because it's positive, yes? So 1, 2, 3, 4, vertex. Yes? And it opens up. Oh, it's wider, yes? So do I need to make it look wide? Now, right now, we don't know what the x-intercepts are, but we will be finding those soon. Just not today,
Wait,
Okay, at least it's
how do you know it's wider again?
because it's 1/3.
positive?
Oh, because positive is wider.
No. Between 0 and 1 is wider. Positive opens up.
Okay.
You do another one?
Yeah.
Don't
have
go
to
on.
graph.
Do not go on.
No.
If it tells you to graph. I don't know. It's a sketch.
There's much easier than other stuff to do. I like the earlier stuff.
No.
It's all
like
pretty
this.
much easy.
It's all the same.
Things I would give
No,
to
it's
do
not.
factoring the whole year.
Okay. Let's do another one. Oh,
No, I didn't want us to.
no. We do. It's another one. Oh, we fun. Okay.
I'm done.
No, guys, look at the problem. It says the vertex of the graph is what? 120. So what does that make 1?
One.
H.
What?
Okay, so it says 120. That makes H
And K.
and K. Yes?
Yes.
And the path of the ball includes the path of
0,
0, 4.
X,
X, Y. And then it says, what is the equation that defines the function? Okay? And then it says, write it like this, but I'll show you that's not hard. Okay, so we're going to do y. We're going to use y equals ax minus h squared plus k, correct?
Yes.
If you write that every problem you use it today, will you know it by the end of the day? Yes. Okay, what's y?
4
4.
equals A, and then 0 minus 1 squared plus 20.
Everyone following where she got all that? She did that fast. Okay, so negative 1 minus 0 is negative 1. Squared?
1.
1. So I get 1 times a is
1.
a.
Or it's just A.
Okay, then how do I solve this? Let's see if we can do it right this time.
Subtract 20.
Subtract 20. So a is.
Negative 16.
Okay, look at the picture. We better have gotten a negative. Why?
Because it's going down.
Because it opens down, yes?
Yeah.
Okay, so now I'm going to put it in here. Y equals negative 16 x minus 1 squared plus 20. Now, this is where it gets kind of just annoying, not hard. So, it wants it in standard form, correct?
Yeah.
Yes, right here? So that means I have to multiply that out. So that means that's x minus 1 times x minus 1. Did we just do that this week? So I have x squared minus x plus 1, which would be x squared plus, not plus, minus 2x plus 1. And then I have negative 16 plus 20, correct? Right here. So I have to distribute my negative 16.
This is not.
It's not hard. Does it take a minute?
Yeah.
A negative times a negative is a,
Positive.
and that would be 32x
Yeah.
minus 16 plus 20. So what's negative 16 and positive 20?
4 or negative 4.
Nope.
No, just 1.
So y equals negative 16 x squared plus 32x plus 4. So this is in what form did we learn today?
Vertex form.
Vertex form. Is this vertex form easier to graph in? Yes. But this is standard form, which we need to be able to factor and all that kind of fun stuff. We will be starting next week going from this form to this form.
No, we aren't.
All the time.
Well, that's
Okay.
super lame.
So are you, but I don't tell you.
Oh! Oh!
Okay,
That
so
was the best roast I've heard today.
so in your assignment today, children, focus. In your assignment today, you're going to be identifying change. You're going to be writing things into vertex form, and then it will ask you to put it into standard form as well. But that's just practicing our algebra and order of operations, okay? Now, I have here, this just shows me, this doesn't give me a whole scenario, it gives me a graph. Do I still have an h, a k, and an x, and a y?
Yes.
Yes. So write it in vertex form for me. Do it. Get it off your picture. What's your h?
Hey.
I forgot.
2. Well, h is 2.
Oh, well, yeah, but.
What's your K?
is 2.
Yep. So try it.
This is it.
What?
If A is 1, does it get narrower?
No, if a is 1, then it's the same as the parent function. Because none of your rules included 1.
10. Your x and y is 0, 4.
Does that matter?
No. It will be, and if you want to state something about it, you would just say same width as the parent function. If you want to make sure you're acknowledging it.
We just have to graph our, like, on here, if we graph, like, information.
Just sketch it. Just
That's what I was saying. I was like, A is 1, so is it wider?
no, it's just the same. Yeah, just a couple. You have to, just one of them. You have to graph it, don't you? Is that more than one?
Huh? Time is it?
That means we have 2 minutes left, Tyson.
Oh, say bye bye.
Does it?
No, finish the problem.
Dang it.
Bell's gonna ring? Okay. Time packed up.
Stupid joke.
What are you hot?
Okay, shh.
What's
I have a message in the